Welcome back. This is the second lesson recording for IM1, March 23rd, 2021. Now we are working on card number 8 of Desmos. Okay, we're going to explore dividing. Okay, so what is 3 divided by 1? That's just going to be 3. What's 9 divided by 1? That's just going to be 9. Which is the bigger number? 9 is the bigger number. 3 divided by 2 is 1.5. 9 divided by 2 is half of 9 is 4.5. What's 3 and which is the bigger number, 1.5 or 4.5? The bigger number is 4.5, so the alligator mouth opens to the right. What about 3 divided by 3 is going to be 1. 9 divided by 3 is 3. And 3 is the bigger number. Notice what happens to the inequality sign when you are dividing by a positive sign. The inequality sign stays the same. What about when you're dividing by a negative number? 3 divided by negative 1, that's going to be negative 3. 9 divided by negative 1 is going to be negative 9. Which is the bigger number or more positive number? That's going to be negative 3. So inequality opens to the left. Notice that the inequality flipped. Okay, it was opening to the right before. Now when we divided by a negative number, it flipped. What if we divided the original inequality by negative 2? 3 divided by negative 2 is negative 1.5. And 9 divided by negative 2 is negative 4.5. Which is the bigger number? It's negative 1.5, right? So again, the inequality symbol flipped. And likewise, when I divide by negative 3, inequality sign will be flipped. Okay, so what you should have noticed is that when we multiply or divide by a negative number, the inequality sign flipped. So let's summarize what we discovered from Desmos. When you have 2 is less than 5, if I add a positive number, the inequality, which is a bigger number between 5 and 8, 8 is a bigger number. Notice that the inequality did not get changed. When I add a negative number, again, the inequality symbol remain the same. When I subtract the same number from both sides, the inequality symbol is preserved. And last, when I subtract a negative number, that is same as adding 3, because subtract a negative is going to be negative and negative becomes positive. 1 plus 3 is 4 and 8. The bigger number is 8. So notice that the inequality symbol got preserved whether you are adding or subtracting a positive number or negative number. That's the conclusion. Addition and subtraction by any number preserves the inequality symbol. However, what if we were doing multiplication? If I multiply by a positive number, the inequality sign is preserved. However, if I multiply by a negative number, it's negative 6 and negative 15. Which is the bigger number? Bigger number means more positive number, so it's negative 6 is more positive than negative 15. So inequality symbol opens to the left, and notice that the inequality sign got flipped. And 3 and 6 divide by positive 3, it's going to be left with 1 and 2, and the inequality symbol is preserved. While as dividing by a negative number, negative 1 and negative 2, which is the bigger number? Negative 1 is a bigger number, and so the inequality sign again got flipped. So thing to walk away from this is that multiplying and dividing by a positive number preserves the inequality symbol as it is. Okay. However, if you multiply and divide by a negative number, like the second and the fourth case, it flips the inequality symbol. So that's the key thing that you need to remember. The flip rule said when the only time the inequality symbol ever flips is when you multiply or divide by a negative number to the negative number. Alright, so I would like you to take some notes. Okay, so solving inequality, here are the things that you need to consider. You want to, what is the goal is to get the variable by itself to find the boundary points, and you follow the same steps as solving the equation. The only thing key thing you need to remember is that with the inequality sign, the symbol remains when you're adding or subtracting any number or multiplying or dividing by a positive number. However, the inequality symbol, the sign, will flip when you multiply or divide by a negative number. So let me demonstrate that. So in this case, -4 is greater than or equal to 3x plus 2. So I solve this, you pretty much follow the same steps as solving equations. If you have -4 is equal to 3x plus 2, what would you do? What would be the first thing you would do to figure out what x is? You would get rid of this plus 2 first, okay? Because x is first being multiplied to 3 and then added to 2. So the last thing that was done to x was adding 2, so we need to undo adding 2, and then afterwards we need to undo multiply by 3. So how do I undo adding 2? You subtract 2 from both sides. That leaves me with 3x is greater than or equal to -4 minus 2 is -6. Okay, now I am looking at negative or 3x is and -6. How do I make this become x? 3 is multiplying to x, so I need to divide by 3. That becomes my giant one, and you're left with x is greater than or equal to -6 divided by 3 is -2. Okay, so far I just subtracted a number. Remember, the inequality symbol stays when you do that. And when you divide by a positive number, the inequality symbol is preserved. It does not flip. The only time it flips is when I multiply or divide by a negative number. So my solution is x is less than or equal to -2. Okay, I find it a lot more difficult for my brain to process when the variable is on the right hand side. So I would always prefer to rewrite this as with the variable on the left hand side. But again, because we're saying that -2 is a bigger number, remember you need to, when you're bringing the variable to the other side, when you're swapping, you also need to flip the inequality as well. Alright, so then let's try another problem. Okay, what if I have 11 minus 5x is less than 26? To do this problem, I am going to again consider what do I do when I have, what do I do when I have problem like 11 minus 5x is equal to 26? What did I do? I know that x is being first multiplied by -5 and then added to 11. So I need to get rid of the last thing that was done to x, which is add 11. So I need to subtract 11 from both sides, because that will get rid of this as a 0, and you're left with -5x is 26 minus 11 is 15. Okay, notice that I just subtracted a number. Okay, so again the inequality gets preserved with subtraction or addition. But look what I need to do now. I need to divide both sides by a negative number, -5. In that case, the inequality symbol is going to be flipping. Opening to the right here, now we need to flip it to the other side. And this becomes my giant 1, and x here, 15 divided by 5 is -3. Okay, so this is my solution, but I had to flip the inequality. Okay, so that's a key thing. Flip the inequality when you are multiplying or dividing by a negative number. Okay, let's take some notes on graphing now. Okay, so previous question, we got the two solution to be -2 greater than or equal to x, and x is greater than or greater than -3. Okay, so this is number 1 and this is number 2 previous problem. The first thing before you graph is check the order. I always prefer the variable first, inequality, and constant. In this case, the variable is on the right hand side, so we want to bring that to the left hand side, and -2 here. And notice that inequality symbol is opening to the -2. That means we still need to preserve that. So this time I flip it because I swapped the order. Okay, so it becomes x is less than or equal to -2. Okay, and then from here you need to put the circle on the boundary point of the number line. The boundary point is the number that you are left with. Okay, when you are left with just the variable and the number -2 is my boundary point, put a circle on -2, and then from here you need to decide, is it an open circle or closed circle? Well, it is, the inequality is less than or equal to, that means it's going to be a closed circle, so I color that in. Then I need to consider which side to shade. Should I be shading to the left or to the right? Since I have the variable on the left hand side first, I can follow the inequality symbol direction. It's pointing to the left, that means I need to shade to the left. Now the last step is important, checking. How do I check? You substitute an easy number to the original inequality to confirm the solution. Okay, so what you're saying here is that solution to the inequality is numbers like -3, -4, and so on. Okay, while as you're saying that 0, 1, 2, 3, 4, those are not solutions. So to check, I find as my original inequality, this is my original problem, and then I find an easy number that is a solution. So like -3 I'm saying is a solution, so I'm going to substitute that into my original equation, and it should come out to be true because that's what you're saying, it is a solution. It should come out to be true whenever you substitute and simplify. So 3 times -3 is -9 plus 2, and the right hand side simplifies to -7. The left hand side remains as it is, -4. Is this a true statement? Is -4 bigger or than or equal to -7? Yes, it is true. So I know that I did not make any mistakes. If you come out as a false statement, that means you made some mistakes along the way. Maybe it's in your solving, maybe it's in your graphing, but you need to go back and check your work again. What about the second problem? We ended up with x is greater than -3. So again, but this is already in the variable inequality -3, so I do not need to swap the order at all, but I need to draw a circle around my boundary point, which is -3, and then I need to consider, is it closed circle or open circle? Well, it's greater than, that means there is no equal sign there, so it is going to remain as an open circle. And then I should be thinking about, should I be shading to the right or to the left? The inequality is pointing to the right, so I am shading to the right. Okay, now to the checking process, I need to get my original equation, which is right there, and I need to find my easy solution. Okay, so here what you, from your shading, you're saying, you're claiming that like numbers like -2, 1, -1, 0, 1, 2, 3, all of this, when you substitute this in, should come out as true. So I pick an easy one like x is equal to 0. 0 is always an easy number because when you substitute that into a x here, it becomes 5 times, -5 times 0 is just going to be 0. So you're left with 11 on the left hand side, 26 on the right hand side, really easy to check, and 26 is indeed bigger than 11, so it checks out to be correct. Alright, so with this, you are going to be working on card number 9 to 19, and it will walk you through and it will give you feedback as to whether you're doing this correctly or not. And then once you're done with that, you can go on to card number 20. And finally, you can enter in your table of content what we did today, which is solving inequalities. Card number 9 is just a quick instruction on what's coming up for the show your work for the next 10 cards on your notebook, and you may also use the drawing pad if you would like to share your work with me to get help. And you will be turning in your notes from today at the end of the class. And when you're graphing the inequality, you will see an image below pop up if you are doing everything correct. If it doesn't, you need to go back.